hello everyone, this is problem 44 of Neetcode 150, merge key sorted linked list. In this problem, we are given an array containing many linked lists, and we have to render the as the output basically the result of merging all the individual linked lists. So this is quite similar to the problem merge to linked list, which is an easy problem in LeetCode. But in our case, we don't only have two linked lists. We might gonna have 10, 1,000, 100. So we have to make sure that we conceive our algorithm to take that into account. So what we are gonna use to solve this problem is divide and conquer algorithm. So we are basically gonna do the following. So let's say I have a first linked list, which is 1 pointing to 2 pointing 3. All right, and now I have 2 pointing to 4 pointing to 6, and I have 3 pointing to 5 pointing to 7. Okay, so let's say that this is my array. So what we are gonna do is called divide and conquer, and it is basically taking a problem and dividing it into smaller problems. So here our problems are gonna be merging. Well, each problem that we have is gonna be basically merging to linked list, right? And since there might be many two linked lists to merge, well, we have many problems. So we're first going to divide this problem by taking these two and using the exact same algorithm as the one in the merge to sorted linked list. All right, and basically this is going to give us 1, 2, 3. Pardon, I forgot a 2. Right, so here we shall have a 2, 2, 2, then 3, then 4, then 6. All right. So now our array is going to be composed of this linked list and that linked list above that we have yet to touch. So this one is going to be part of the next array. Okay. All right. And then once again, we are going to take the two linked list and link them into a single one. So I don't want to write the entire linked list because it's going to consume a lot of time. But this way we can actually have a pretty decent time complexity. So dividing itself has a time complexity of log of k, and since we have an amount of elements on each linked list, we're gonna have a total time complexity of big O of n log k, right? So this is gonna be your time complexity. And now let's go ahead and solve the problem. All right, so first thing we have to check for is we have to make sure that we handle the edge case where there is no list, there is nothing. So if not list, or the length of the list is 0, this is something to consider. We're going to return false. All right. Okay. So now let's go ahead and write the divide and conquer algorithm. So we are going to be willing to end up having an array with only one linked list. So we are actually going to use a while loop until the length um, of the list is greater than one, right? Because if it is one, it means that we merged all the linked lists within that array. So this is the while loop we are going to use, and then we are going to have to. I will create another array. So we are going to call this um, merge. So merge list. All right. And we are going to go through all the values, well, all the linked list in the array. So we are going to use a for loop. So y in the range starting at 0. Okay. All right. So within our for loop, um, we want to set like the list one. We basically have a list one and a list two, and the list one is going to be the first one. So it's going to be at the index I, where the list two is going to be the list, well, the list at the index I plus one. But we have to make sure that I plus one is actually within the within our bounds, so it has to be smaller than the length of list, right? Okay. Otherwise, we are just going to return none. And after this, we are going to merge this to our merge list. So yes, so in this exact line, the 17, we are basically going to use a function that we are going to write ourselves to merge the two linked lists. So this function is basically going to be the exact same function as the one we used in the problem merge two linked lists. Okay, so merge, let's just call this the merge function, right? So it will take, let's say L1 and L2 to make it short. Okay, and let's just define this later. So it's fine if we just continue with the or divide and conquer algorithm. So what we are going to do is that we are going to use the merge function, right, for list one and list two. Okay. And after all this, we are going to set the list equal to merge list. And you want to do this because after all these rounds, well, let's say you have 4 lists, right? So for I and like for every I, we are gonna have a list with basically 2 elements, right? Because if we have 4 linked lists within our array, after the for loop, we are gonna have the list 1 and the linked list 2 linked together, and link list 3 and linked list 4 linked together. So this is why you want to set the list equals to the merge list, because it's gonna have 2 elements and it will keep looping basically through it. All right. So after this, we can return basically the head of the linked list, which is going to give us access to the entire linked list. Okay. And now it is our time to define the merge function. So if you recall, we have to create basically a list node that will point to the first element or the head of the new merge list. And we also have a runner, and that runner is basically going to go through every single node in that link node, and it's going to assign the smallest value between. So I think I will just go shortly over it. Feel free to skip this part if you already know it, but I will go over how to merge two linked lists. Just for an example, basically we have, let's say, 1, 3, and 5, and then we have 2, 4, and 6. So we are gonna have our first pointer here and our first pointer here, and let's say we call like this link node the start, right? So we are gonna have a runner that will move to the first element, and it will basically set that next element equal to the smallest value between both. So here is going to be 1, right? Then we are going to compare 3 and 2. That runner is still going to move to the next value, and we'll set that next value to 2 because it's the smallest between 2 and 3. Then we are going to compare, right? So I think I gave you a good enough idea, and we can go ahead and start this. So let's say start L for the start of the list. This is going to be equal to a list node. And we have a runner, which initially is set to that same start list. Okay, and now we are gonna go using our while loop until either list 1 or list 2 is running out of bound. So L1 and L2. All right, and what do we want to do? We want to check if which value is the smallest. So we are gonna set our first if statement in the case where the L1 is smaller than L2. All right, so just like this. And if it is, we are gonna set our runner runner that next. This is gonna be equal to that L1. All right. And we also want to update L1 so it doesn't always compare the same head element. So L1 is going to be equal to L1 dot next. That's how we do it. The other case, so let's say that either L1 is greater or equal to L2. We are just going to set our runner dot next equals to L2. And we're going to set L2 equals to its next value. Following way. All right. And then we are also going to move the runner. So the runner doesn't always update the same exact value. It keeps moving. So we're going to set the runner to its next value this way. And finally, we have to handle a case where one of the two linked lists, which is highly possible, is not the same length as the other one. So we are simply we are simply going to set that if L1, so if L1 still exists, right? So the next value is going to be equal to the rest of that value. Otherwise, we still have to write an if statement. So if there is still a L2, right, you get the drill. It's going to be set to, okay. And after this, we have to basically return the head elements. Notice that right now our start L is pointing at the first element. So we are going to basically set start L dot next. And this is going to give us the entire link list that is fully merged. So I hope I didn't do any typo. Well, the best way to test that is to actually submit it. So let's see this. And I got an error. So I did a subtle error here. I placed a 1 instead of the I. And also I didn't include my S for a list. So let's go ahead and submit this. And there we go. You see, we succeeded at problem 44 of Neetcode 150, a hard problem. I hope you learned from this video, and I hope to see you in the next one.